Hello everyone and welcome to Java Basics. Today we will finally create a version of the Wordle game that looks really close to the real thing. We will do this with the magic of SPA, Single Page Application. I won't do the whole on-screen keyboard, but it will look very close and have that same interactivity. Before I explain what's an SPA, let's take a moment to talk about the code. As it was the last time around, the code is available here. It's in the description too. Don't forget to start and follow me on GitHub while you're there. And here too, while you're at it. What is a single page application? To explain that, let's first revisit the application we built the last time around. In a regular web application, we send a request to the server and get back HTML to show to the user. This works great and is relatively simple to write, but it creates a problematic experience where we see the browser loading interface and then the page rebuilds itself from scratch. This isn't ideal for some applications. We're building the entire page sometimes just to change one value. That's a waste. It's also not the best user experience. Look at sites like social sites. As you scroll, the site would bring more content without refreshing the page. How does that work? An SPA starts exactly like this for the first request, but then something changes. The HTML is now running on the browser, and the JavaScript within that HTML page starts sending small web service requests. These requests return JSON instead of the full HTML. That means we can make small updates to the page instead of fetching the entire thing. The cool thing is that we already implemented the server side for this. Remember the guest web service we built when we started working with Spring Boot? That can be our backend code. All we need to do is write the web frontend. Previously, we created most of our code in the templates directory because we use Thymeleaf. But for the SPA, we can leave the HTML as is. That means we can create all of it in the static directory, as nothing needs to change. I'll skip the file creation logic and go right into the code. First, we'll create the file wordlespa.html. Let's go into it. The HTML is pretty standard so far. We declare that the language is English, and the one thing I skimmed on previously was the encoding. We define it as UTF-8. Encoding is complex and nuanced subject, so I won't delve into it all of that. But I will say that this lets us type characters that aren't English, Latin characters into the HTML. This is another line that we typically need to include in any HTML file. I didn't include it previously, but it helps keep the HTML responsive. If you don't have it, then the HTML will look like a zoomed out page when you run on a phone. Previously, we wrote the CSS in the HTML file. That's okay for a small amount of CSS. But if we have a lot of CSS, this can get hairy. If you want to use the same CSS in many HTML files, you can include it like this, and that way your page can have the same styling. You can include multiple CSS files like that. That's why they are cascading style sheets. We can then have a common theme for all the pages and specific customizations for some of the pages. The rest of the body is pretty trivial. We have the title and the game board div. This is where we will see the actual Wordle game. Finally, we have a script tag. Just like CSS, we can include an external script file, which makes this more convenient. Just like with CSS, we can use the same JavaScript file in multiple pages and include many scripts. We don't need that functionality in this case. With this, our HTML is done, and we can move to the CSS, which is more interesting. We first style the body tag in the HTML. Notice that syntax like this selects the HTML tag itself. Since the body tag wraps the entire page, this will apply to the entire page. These things are hard to grasp without visual aid, so let's start by showing the final result here. We can then contrast it with the way the same page would look without the CSS block. Notice that the text is left aligned, but more subtly, notice the color of the page. It's white instead of off-white color from before. This makes the difference between the entries and the background less subtle. This is an even more subtle difference. We select the h1 tag, which is where we wrote the Wordle clone string. An h1 is the largest heading text in the page. We define that it would have additional margin at the bottom, which increases the space a bit. This isn't essential, but helps the UI look more professional. This is the content of the actual game board. Notice we used an ID selector with the hash prefix to target the game board entry in the HTML. There's a lot to digest here, so let's go line by line. The display entry indicates to the browser how we want the content arranged. In this case, we wanted 6 rows where each individual element takes up one place. This looks like a method call, but it isn't. It just hints to CSS that this is a repeating pattern. We define a gap between the individual rows. Notice that on the right-hand side picture, the rows are tightly packed. We also define the maximum width. For simplicity, I used pixels here, which isn't ideal. But this isn't a front-end development course, so we'll let that slide. Removing this line will cause everything to spread horizontally, as you see on the right. We remove the margin auto things will align to the left. With this syntax, we can define the top and bottom margin differently from the left and right margin. When we add a row, we will give it the row class. These are added dynamically in the JavaScript. We again add a grid within the grid. In this case, it's divided to 5 elements, one for each letter, with a small gap in the middle to space out the letters. Without this grid, the browser will default to drawing them in sequence. The letterbox entry is assigned to every individual character and makes it look like a proper square with rounded borders. There's a lot here, but it's mostly simple stuff. We set the width and height to fixed values, so there will be room so the entries don't shrink. We set the background to white and define the border radius to get the rounded button look. We define an outline to the border to further make that separation distinct. We define the front font to be bold, slightly larger, and center aligned. Finally, we block user selection of the word so a user can't copy and paste. With this, the CSS is completed and we can move to the script.js file where the application is implemented. The first line defines a variable for the game board, which we find by its ID. We did this before, but I want to point out something I left unsaid before. Notice there's no class. We define the variable just like that. This is a global variable. It's something that doesn't exist in Java, for better and for worse. In JavaScript, we can just write a variable anywhere and it will be initialized when the browser reaches that line. Next, we define a constant for the number of attempts. This is better than just writing 6 everywhere. If we want to change it later on, we can just change it in one place instead of looking through our code to find the mentions of 6 that might refer to something else. Up until now, we only defined constants with the const variable. The let keyword lets us define a variable that is modifiable. Notice we don't give the variable a type. JavaScript still has types, just like integer, string, and boolean, but it declares decides on the types based on the code. These variables let us know the current state of the application, specifically the row and column we're on and what's the current guess. Next, we will define a new function. A function is similar to a method but has some nuanced differences. In this case, it isn't associated with a class. Notice we don't have a return type since there's no types in JavaScript. In this case, the function doesn't take parameters. The for loop is practically identical to the one in Java, but we use the keyword let instead of int to define the iterator variable. That's simple enough. But the next line is the interesting part. Up until now, we found elements. This time, we're creating one. This is like writing a div tag in the HTML. We can dynamically create a new div tag from the JavaScript code. Notice it isn't placed anywhere yet. We need to add it to the HTML, or in our case, to the document object model, the DOM. Once we do that, we can change the HTML dynamically to anything we want. Remember that we styled the row in the CSS. In this case, we define a CSS class for the div element we just created and give it the row style. Notice that you can have multiple style classes associated with a specific div. In this case, we don't need that, but as you learn HTML and CSS, you will find this very useful. This is a loop for every row. Within every row, we need the 5 letters of the word. So we're nesting a loop within this and going over the 5 elements. Here we create a letterbox for every letter and giving it the class style of letterbox that we defined in the CSS as well. We can set the ID of the letterbox div that we just created. This will let us find that individual div later on when we need to do something with it. Notice that this works exactly the same as writing an ID attribute for an entry in the HTML. So getElementById with the row and column will work as expected. Notice also the dollar and curly braces syntax. That's a special syntax in JavaScript that lets us replace the content within the variable values. This means that the row 0 and column 0 will get the string letter -0 -0, and so forth. It's more convenient than writing lots of plus signs when joining strings together. Finally, we add the character to the current row. Now it's a standard part of the row hierarchy and will appear as we expect it in the row. We now need to add the row to the game board, which we do like this. With that, we dynamically construct the entire game board. We could have just written a lot of div entries with the right ID and class attributes. It would have worked exactly the same way, but it's not as flexible as just generating the divs dynamically. This is an interesting part. We have the method that checks the guess made by the user. Notice it accepts the guess string as an argument. In JavaScript, it's enough to just give it the name of the argument without giving it the type. But the interesting thing about the method is the async keyword. This method is invoked by the browser. This means that when the user enters the word, the browser needs to send a web service request to the server. If it did that, the UI will block while waiting for the network connection. Computers can run more than one thing at once. In Java, we use threads for that. I will cover that later. But for JavaScript, we can perform tasks asynchronously. That means that this function will run in the background and return its result when we're ready for it. We will see that return soon enough. We invoke the fetch function that accepts a URL. I don't include the server since it's a URL in the server we came from, the origin server. We use the get method and the URL should be familiar to you. If you remember the old guess web service we built when we started with Spring Boot, it's that exact unmodified web service. Notice we pass a header requesting JSON. This is important as it hints to the server that we want to get a response as JSON. But the important part is the await. Fetch is an async function. When we invoke it with await, it waits for it. In normal Java or JavaScript code, the calls are asynchronous. That means that when a function A invokes function B, it does that in sequence. When function A invokes B, it suspends its execution and won't continue until function B returns. This means that it's blocked and can't continue to function C until it's done with function B. Java works this way too. Just replace the word function with method. When we call an async function, JavaScript returns immediately, before the function actually ran. So we don't have to wait for async function B as before. Function C starts running. Function B will run in the background. This is important for things like networking or reading a file, as these things can take a lot of time and we don't want to wait for them. But what if function A is asynchronous too? There's no point in running function B in the background, whereas function C might need the results of function B to proceed. The await keyword invokes the async function and then waits for it to finish. This isn't like sleeping though. It doesn't fully stop the computer from doing things in the background. Other things can keep running while we await the result, and the code feels like regular synchronous calls. This is pretty cool feature, but it has some drawbacks, such as shorter stack traces. When we try to debug JavaScript code, it's really hard to see which function invoked which one because all the functions are invoked asynchronously. If there's a failure in a function B and we print the caller to function B, it isn't function A. Getting back to the code, since check guess is asynchronous, this call doesn't block. But since fetch is also asynchronous, we use await to wait for the response from fetch. Otherwise, we wouldn't have the return value from the function. Getting the JSON response is also an asynchronous function. You will see this a lot in JavaScript. Anything that can potentially block will be asynchronous. Otherwise, the browser will freeze and the experience will be pretty terrible. We return the result of the guess, which, if you recall, is JSON. JSON itself integrates seamlessly in JavaScript. That means that the JSON appears as an object even though we didn't define a class or the fields of that object. This is both good and bad. The good side is that we don't need to write any code. The bad side is that the IDE can't really help you with code completion, and you don't get completion errors if you did something wrong. Next, we define the function that's invoked when we get a result from the server. The update board function accepts the result object, which is the JSON returned from the server. When we get the result from the server, we go over the 5 characters in the line with a for loop. Remember that we created the character entries. We gave each of them an ID based on the row and column. The current row global variable represents the row we're in. Now we go over each of the characters in this row and get the DOM entry so we can paint the result. Since we return an enum with the colors from the server, we can switch over the array of the results. If the current entry is green, we can set the background in the style to green and the foreground to white. This is essentially the equivalent of defining CSS for green and white. The switch element is syntax that is identical in Java and JavaScript. You can take that code and write something that looks the same in Java and it would work. The switch accepts an entry with a value. In this case, a string. In the case where the string is green, it will execute the code in the green block. Notice that each block in the switch case statement ends with the word break. This is an oddity of the syntax for this variant of switch. Notice that there are more variants, but I won't get into them right now. If you don't have a break between green and yellow, the execution of green will continue and execute yellow too. This might seem stupid at first, but imagine a case like this. Gray is spelled differently in the UK, and we might want to support both versions. This is a very common scenario for switch and is the explanation of that syntax. Also notice the default keyword at the bottom. It's a special case that runs if none of the other entries matched. Notice that this is Java code and would work as is both in Java and JavaScript. The final entry for black is pretty much identical, and with that, we complete the switch and the for loop that surrounds it. We paint the individual letters with the right colors when this method is invoked with the results. How do we know if we won the game? So we can show that to the user. This function loops over all the characters and checks that they are all green. If even one of them isn't, it returns false. If they are all indeed green, we will reach the last line where true is returned. Once this is done, we can use the isWhen function to show a you won message. One of the cool things in Wordle is that it doesn't have a text input field. We type a letter and it appears where we expect it to be. We can accomplish that by listening to key events which we receive asynchronously. There are several interesting things here. First, this is a global call. That means this will happen right as the line is reached when the page loads. As the page loads, the browser reads the HTML and the JavaScript code line by line. It executes all the global code, including this line. We use the global document object, which represents the entire page. We process the event asynchronously, so it won't block execution. We get one argument, which is the event object. The arrow syntax in JavaScript is slightly different from Java, but has the same basic meaning. The code within the curly braces will be reached when a key is pressed in the keyboard. We get the current letter typed by the user from the event object and convert it to lowercase so it will be consistent. This is a big one. We use the match method to check if a letter is a valid English letter. Notice that this might not be the case if your keyboard is set to a different language. Notice that weird syntax the match method received. That is a regular expression. A regular expression is a special pattern matching syntax. It's a general computer concept that's not specific to JavaScript. The control character represents the start of the string, and the letter range indicates what an acceptable value would be. I won't dig too much into that syntax since it's a huge subject in its own right. We will only process the next character if we have less than 5 characters for the current row. Next, we need to find the DOM element for the current row and the current column so we can set the character to that element. We set the value of the letter in the element and add it to the current guess global variable. We finally increment the current column value. This means that with every letter typed, we will move to the next character. If this isn't a letter, it's possible the user pressed backspace to delete the last letter. We can check the key code to see if that's indeed the case. Assuming that it is, and we're not in column 0, which would mean we have nothing to delete, then we need to delete the last letter entered. We reduce the offset of the column, we shorten the string of the guess by 1 character, and we set the value of the letterbox to a blank string. If the current column is the last column, we need to check the guess on the server. Obviously, we can't do anything until the guess returns the result, so we use the await keyword to wait for the result. If the result isn't null, we update the board with the code we saw before. Notice that the result from the server will be null in the case of an error. Notice that the JSON includes a results array, which is what we pass into the update board method. The reason for that is that we don't have error processing code in the update board method. In that case, we display an alert with the error message that's part of the result. So the user will see the server error message. If we won the game, then we need to show this to the user. The syntax is a bit weird. The set timeout function is used in the result processing to delay the execution of the provided function by 500 milliseconds, which is half a second. We use set timeout to create a brief pause before displaying the alert message and reloading the page. The pause helps ensure that the visual updates on the game board are complete and visible to the user before the alert message is shown. If we didn't win, we implement the we increment the current row. Before we proceed, we need to check if we crossed the maximum number of tries. If we did, we show an error message using the same timeout trick we used before. Again, we call reload on the location object to refresh the page. The location object represents the URL to which the browser is pointing. Think of it as the code representation of the browser address bar. If we still have tries left, we reset the current guess and set the column to 0. Since we already incremented the row, we are now at the start of the next row and all should work as expected. The one last thing to do is to generate the initial game board. We do that with a global call as well. With that, the game is complete and ready to launch. Let's go to the browser and see what we did. In the browser, I just open localhost 8080 wordle.spa.html. This is just a static page, but it communicates with the backend logic. I can type in various words, and just as I finish typing with no additional action, they get colored as expected based on the same results as previous videos. Under the hood, every time I type the fifth character, a request is sent to the web service we built in Spring Boot, and it returns the result to the JavaScript code. Notice that colors work for all the types, and when I win, I get an alert from the browser. When I type a bad word, I get an error from the server. And when I use backspace, I can delete characters as expected. With this, we have a Wordle clone that is almost complete, but there are still a few improvements to make and a few lessons to learn. We did a detour on the front end for the last two videos. Next time we will go back to the back end. We will dig into databases, object-oriented theory, and more. If you have any questions, please use the comment section. Thank you.